Okay, so I have not yet started grading the midterm. Any comments on it? Was it too difficult, or was it similar to what we have been doing in the class?
I didn't think it was bad.
Okay. So as long, since you are using your own computers and you have all the MATLAB codes available to you, so it would not be that difficult even for the final exam, which is roughly in a month. So it's important that you write out all the codes that we do in class, and hopefully write them out as we go through the lectures. And if you haven't, the video lectures are there. Just go back and again write down those codes on your computer, because that would help in the exam process. Okay, so if we look at the schedule, we are almost close to the end for MATLAB. So we are done with these 6 lectures. Today we are going to do while loops. And this is the last bit of hardcore coding tool that we are going to learn from this class. What we would have left are basically the applications, plotting different kinds of graphics on MATLAB, and then the applications on how we can use this kind of tools to solve actual mathematical problems. But I think the hardcore part of the coding, the logical reasoning, the algorithm development, they sort of wrap up after this lecture today. And then we plan to have the final exam on October 8th, after which the next instructor, John Verstick, is going to take over. Okay, so this is the last bit of conditional logical structures that we are going to learn, in addition to what we have already. So we have learned if, else, else if, and if, else if, else and structure. We have learned what is for. So today is the day for the while statement. So this cartoon over here is the generic structure of how while works. It's kind of very easy. So you basically set up a conditional expression right after while. And as long as that conditional expression is true, it is going to carry out this set of operations. And then you use an end. So the only challenging thing I think for you guys is to figure out, when you see a problem, whether to figure out if it is a problem for if, or if it is a problem for, or if it is a problem for while. And sometimes it's quite easy to figure that out, because if we are thinking about the homeworks or for the tests, the problems that I would give you would be very similar to the examples that we are doing. But in general, if you think about the distinction between if statement and for statement, what was the main difference? On if, you had multiple conditions, right? So you could test the first condition right after if. You could test out multiple conditions after the else ifs, and then whatever was left was tested after else. So you had multiple conditions, and you could run multiple number of mathematical operations under each of those ifs or else ifs or under else. What did we have for for? For for, there was an index variable which was incremented by 1 in each step, and that index variable was a factor, was a player in the mathematical operation, just like we did the series sums. But that index variable actually was there in the algebraic formulation of the series sum. So there is just one parameter which was being incremented. And what we are going to see for while is, there is a conditional expression which is going to be tested in each of the run. So as long as that condition is true, it is going to keep on running that particular set of mathematical operation, and then it is going to stop. So that way, it is slightly different than how if was, where you had multiple conditions, how for was, where there was an index variable which was a player in the mathematical calculations. Over here, you just have one condition which is going to be tested in each run of the loop. So I think that's what I have tried to explain over here, but I think it would be clearer as we write out an example code. So we are going to solve this together, and I'm going to ask you what are the different lines or different steps of the algorithm that you think we would need for this one. The generic structure of the code being while, conditional expression, the mathematical operations, and then end. So with this background in while, let's look at this particular problem. We have a variable x. The initial value is 1. Now create a loop that updates the value of x to twice x By the way, let me check the chats. It seems like there are many chats coming up. Okay. Oh. You guys can hear me, right?
Yeah,
Yep.
we can hear you.
I get scared with the chat things coming up. Anyway, so this is the question. We have the initial value of the variable to be x. Create a loop that would update the value of x to twice x in each run until x is 100,000. So this sort of would help you to set up the condition. Now, what is the output that they want? Make a table with the first column being the iteration number and the second column being the value of x at that iteration. So I have actually taken a screenshot of the output from my MATLAB. So this is what we have to generate here, but the first column is the iteration number 1, 2, 3, 4, 5. And the second column are the numbers for x until x doesn't exceed 100,000. So for example, it stopped over here because 65,000 something, double of that would be 130,000 something, which would be exceeding 100,000. So that is defining the condition that this problem has. So the output is going to be like this. First column, the iteration numbers, and second column, the updated values of x. So I wanted to include this screenshot to help you guys think on what your algorithm is going to look like. So we are going to write a script file for this, not a function file. So the first steps are, of course, clear all. Sorry, clear all, close all, CLC. Now, anyone, tell me what do you think would be the next step? Take a moment to read the problem, think on it, and tell me what do you think would be the first step?
Should we have an initial value of x equals 1 before the loop?
You're right. We add an initial value of x equals to 1. Because that's the value of x we are starting out from. And that can be initiated outside of the loop. Correct. What next?
We probably start the while loop.
Okay, let's see if that works. So while, what do you think the condition is going to be?
X is less than 100,000.
X is less than 100,000, correct? What do you think the next step is going to be? So now think about what you are trying to generate, that 2-column array.
Should we also have an iteration variable? So maybe like I equal to 1 at the very beginning?
Yeah, you're very right. So we need an iteration variable because we want that iteration factor as one of the outputs as well. So initially I is 1. Correct. So what next? So you guys are very right with this initial variables, which is x1, I1. I don't think we would need anything outside of the loop. Let's now think about what would go on into the loop. And before we do that, let's type out the end to make sure that we have the loop ending line. Okay, so let's now think about the loop. And while we think of that, let's think about the output. So we need a matrix, the first column of which is this iteration factor. So if we call that matrix to be as answer, how can we write the first column in terms of matrix format? What should be within this bracket? So for example, if we had A to be 1, 2, 3, 4, 5, 6. So if this was our matrix, if we had written something like this, A1, that just gives you this one single element. Or if I write A3, that gives you, because MATLAB control goes column-wise, it goes through this particular element, 1, 2, 3, and that is the output. But if we are thinking about the entire column for A, which in this case is 1, 4, what do we write? If we want to have the first column, we would probably go with something like this. So just the first column, so all the rows, so colon for that, and the first column is this. So we get the first column. So we need two placeholders. But over here, what should be the corresponding setup? Well, where you are basically associating that particular column element with the iteration factor I, because that's what goes into the first column, right? So what should I type in over here? Okay, an easier question first. What should, so if, of course, there will be two placeholders separated by a comma, what should be the second one?
She is a big fan of those flavors.
Would it be
not
2x?
as big of a fan. I can take it or leave it.
We are thinking about the first column, remember? So the 2x is actually going into the second column. So again, if you look back at our earlier lectures, the way we set placeholders, this part is standing in for the rows, this part is standing in for the columns. As I said, we are thinking about what to output in the first column. So what should be this particular number?
So should that be 1, and then in the first part there it'd be I?
Exactly. And what should be on the right-hand side? So what are we assigning to that particular column?
So we're assigning I to that column, so we'd put I.
Okay,
So
okay, you're right. So this is it. This is how you set up the first column. Answer I1. So basically, as the value of I would be changed, which we can do later on in this loop. But that particular element, so over here, this particular element is 1, 1. So 1 gets associated with that element, with that place. Now, if we come to this, so here the corresponding row number is 2, but the column number is 1. So the updated value of I would be assigned to that. So think on this for a moment and let me know if you understand this or if I need to explain this again. We are basically assigning all the elements, which are I in this case, to the first column, and hence this is 1. And all the elements are I, which are being assigned to this row place. But as I said, the I has to be updated because otherwise it would just be using this one single value of I. So in each run, we would have this extra line as well. I is equal to I plus 1. So this would ensure that in the first run, I is 1. And as the control goes back to the beginning of the loop, I gets incremented to 1 plus 1, 2. And then we go to the second place of this first column. And then in the second run, I gets again updated to 3. And then we get the third place in this first column. Okay. How would we set up this second column here now? So of course, the approach is going to be similar. What do you think should be this particular line?
Will it be 2x, and then we're gonna have to update x in another line?
Would it be 2x or would it be something?
2 times x.
Remember the row number. So
wouldn't it just be 2?
that would just be 2 because we are just in
Okay.
the second column now, not the 2x. We would think about the 2x when we are trying to assign something to that class, which is on the right hand side. So we are assigning that 2x to over here. Okay, so let's now think about this particular line. What should be this one? So this is again the row number, right? So we are going to assign this 2x to all the rows. So the row number is connected to the I value, because here it was the row number and everything was I. So this is just I, because when I is 1 and this is still 2, we come to this particular element, which is the first row, second column, then we come to over here. But the row number is controlled by the iteration number, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All good. This is starting to make sense. But then let's think about something else as well. So you have assigned 2x to the second column. Can you tell me what the output is going to look like in the very first run? So if we start out with 2x, what would be stored in the second column in the very first run?
It would be 2, right?
It's not what we want, right? The output should look like. So what if we keep this as x, so that it can store that x is equal to 1 in the first run, but then update the value of x in each of the subsequent runs. So make it like this, just like we are updating the value of the variable I over here. We update the value of x in each run, and then in the second run, it will store the value 2 instead of the 1, because it has been doubled by this factor here. Does it make sense? Okay, so I think we have a code that makes sense now. Let's write out the output line. So we just answer. So let's try and save this and try to run this and see if it works. This is 7. So it ran fine, it compiled fine, so there is no coding error in there. So if we type answer now, we get the output, which is exactly the thing that we wanted. So this code worked. Anyone else got this as the output? Or anyone didn't get it, even though you are following my coded lines here? Any questions on this one?
No.
Okay. So it is. So the first things first. So on the test, I won't give you this kind of output screenshot. So I think it helps if you can just jot down the kind of output the question is asking for. That would help you think of the logic in the loop. And the same thing holds true for the homework questions. Try to figure out what the output is supposed to look like, and then write your code. And it is not only for the while statement, it holds true for the if and the for as well. So there should be a visual that should guide your algorithm development process, because that helps. Otherwise, if we didn't have this kind of graphical visual in front of us, it would not be that easy for us to figure out that it is not going to be 2x in this line, it's rather going to be just x. So make sure that you use this kind of tools while you write your code. It's just easier. Okay, so this was the first example. I hope now the while statement is making some sense. So basically it is going to test some condition. And as long as that condition is met, it is going to carry out whatever operations you ask it to carry out. Okay, so over here, I've tried to explain different nuances for this particular problem. I've tried to show out the different errors that you can have. You can just follow the code that I just developed, which is very similar to this code, this screenshot here. But you can play around with it as well. It makes sense to play around with it because then you get more practice on how to develop a code for a different problem. and here is the output. Okay, so let's now think about another problem, and let's take a moment to read this. So a rocket for testing wind shear in thunderstorms is being developed. The goal of the rocket is to launch into the thunderstorm, transmit data wirelessly to a satellite, and then crash land back on Earth. Computer simulations show that the height of the nose of the rocket as a function of time is given by the equation below. So what essentially do we have here? So we have the function of we have the height as a function of time. So this particular expression is depending entirely on time, and the logic being the height of the rocket would be different at different time instants. So what we have to do is plot the height of the rocket versus time. So basically plot this function as long as the rocket is in flight. So you need to read these kind of problems a little carefully to figure out what the condition is going to be, because eventually you want to frame it in the form of numbers and algorithms. So you need to figure out what the condition is. So this last line tells you what the condition is. You have to plot out that HT as long as the rocket is in flight. So it implies that this H, as long as it is a positive number, it is greater, because when the rocket has crashed into the ground, that height is probably equal to 0. So as long as it is not 0, it is greater than 0, it is still airborne, and we can still plot whatever the height of that rocket is when it is still in the air. So that this last line will determine what your mathematical condition is going to be. So let's now think about this particular problem. Again, we are writing a script file. So clear all, close all CLC. So if you want to take a moment to read this problem, read it, but tell me what the next lines are going to be, or what are the different things that we need to initialize outside of the loop.
You need to write the function.
The function is dealing with the core mathematical calculation that the code is going to do, right? And it's going to test if the height is still positive, implying that if the rocket is still in air. So that would go into the loop, not outside. Outside, you basically initialize some variables, which can be used as the initial values when the code runs the first run of the loop. So outside,
So you need like an index variable of 1, and then like a t value of 1 maybe.
but a t value, I think we should start with t is equal to 0 instead of 1.
Yeah.
So it's the time. So let's start with time step 0. I don't think we technically need anything else. Let's start writing the loop now. And of course, while developing a loop, you realize that you need something else as being initialized outside of the loop, and we can come back later on. But these are the good points that we can start from. Let's start with the loop. So the loop is, what is the condition, mathematical condition for the loop?
H is greater than 0.
H is greater than 0. Sounds good. Now tell me, instead of going into the mathematical operation, once MATLAB tries to run this code, the moment it comes to this line 8, you would encounter the condition that H is greater than 0. Does it know what H is yet?
No.
It doesn't. Any suggestion how we can avoid that? So what is the initial H at time is equal to 0?
60.
So I think we should have this line over here, because once MATLAB encounters this condition in the very first run, you don't really have to worry much from the second run onward, because there would be some mathematical operation that you are going to write over here, and it would be able to calculate the new H. But for the very first run, it would try to test out that condition, right? And without knowing H, the code would break right over there and you won't get any output. Just like in the previous example, we had to initialize what is x because otherwise it doesn't know what is x when it starts out. And then you can update the value of x. Here as well, the value of h is going to be updated through this equation, but it still needs the initial value of h because that controls the mathematical condition. Okay, so let's now think about the mathematical operation that we need to carry out. So of course, the obvious first step would be to write out this equation. So let's do that. So h is 60 plus 2.13 t squared minus 0.0013 times t to the power of 4 plus 0.000034 times t to the power of 4.751. Okay, so this is the h. So in each step, it's going to take in the value of the t and the value of the h to figure the value of the t to figure out what is the current value of h. Sorry, there is a typo here. I had caps t, so small t. Now to calculate this particular equation, what else do you need? So initially the value of t is 0 and it can calculate h, but we need to change the value of t, right? Because from the next run onward, you want to track that height for different time instance. So how do we change the value of t?
Does it depend on like how many points we want on our graph? We can probably just do t equals t plus 1.
Yeah, you are right. So t is equal to t plus something. Let's try with t is equal to t plus 1, and we can change that later on if the plot looks too bad. So let's have it as t is equal to t plus 1 for now. Okay, so hopefully the t would be updated, and in each run, so in the first run t would be 0, but in the second run onward, whatever the updated value of t is from this particular line would be used in this equation. So that is fine. Okay, so let's now think about how to get the output. The output is, of course, the plot where we are plotting the height and the time. So when we think about the plot, so we have done some examples with plotting functions. So basically we are thinking about plotting something like this. So the first parameter over there is the x coordinate. So in this case, the x coordinate is going to be time and the y coordinate is going to be the height, right? To plot that. So basically what we are trying to set up is a series of values or a range of values for t and the corresponding values for h. So we are thinking about setting up a data set for h and a data set for t. And how do we do that? So this is just a single value of h, right? So we need to set up an array of numbers which are going to correspond to the different values of heights at different time instants. So any suggestion on how we can do that to store multiple numbers, multiple values for h into one single array? So let me give you some hints. So suppose we are trying to plot the height. If we type out height I, where I is sort of like an index variable that is going to be updated in each run. So if height I is h, then as MATLAB goes through each of the loops, each of the runs on this loop, it would store the value of h into this height I, right? And to ensure that it does happen, we have already initialized I as 1, but we do want to change the value of I as well. So we add this one line at the end. So in the first run, height 1 is the h that is computed in the first run. In the second run, I gets updated to 2. So height 2 would be that new value of h. So that way we can store all the possible values of h from all the runs into this parameter called height. Okay. So going by the same logic, we also need to set up a storage system for the different time instance, right? So what do you propose the line should be for storing the time?
Time parenthesis I equal t.
Yeah, so the name of this variable is up to you. So I'm calling it time I is equal to small t. So you have to make sure that whatever you are assigning is agreeing with the mathematical equation here. So you calculated h, and that h got stored here, and t is a dependent, an input parameter into the equation, and that small t is being stored in the time. Okay, so I think it is making sense now. So if we can run this loop, hopefully all the height values and all the time values are going to be stored under height and under time respectively. So that is not everything. We also need to generate a plot. So how do we do that? So to generate the output, so to generate the output plot, we're going to use the plot command. And what would be along the horizontal axis?
Time.
Time.
Would it be time I or just time?
Time I.
Okay, let's try that out.
Wait, no, it'd just be time. Yeah.
Just be time, because if you have time I, then once you have exited the loop, the final value of I would be used, and you won't get a plot. You would get a single point. It would be the entire series, which is just time in this case, and then height. Okay, so let's set this. And let's run this. We have this output showing up here because I missed a semicolon here, but that's trivial. So this is how the plot looks like. This is how the height varies over time. You see that it dips below 0, so it technically becomes negative. That is because the way the mathematical function is, initially the starting point was 60, and when it fell down, because of the mathematical form, it became negative. So I'd be happy with a plot like this. It doesn't really matter in terms of the overall problem. Now, on the other hand, if we didn't have, so initially we didn't have this particular line, the initial height. If you had tried to run it then, without that line, you'd see an error which would actually tell you that MATLAB found this to be unrecognized. So that would help you to debug your code as well. So don't get too worried or scared to remember each and every line. Even if you get an error, it is always possible to go back to your code and try to correct it and debug it. Any question on this one? In the next lecture, we are going to work on making how to make the plots look all pretty, but for me, this is sufficient for now, this kind of visuals. So I have added the screenshots for the code. Okay, so this is one thing that I wanted to discuss with you guys at length. So if you go, so I have included this link over here. If you go to this link, you would see that there is a MATLAB on-ramp thing over here. So it's a free certification course, which you can do, and this would beef up your resume as well. Because as of now, you are just doing a coursework on MATLAB, but if you can show the possible employers that you have a certificate directly from MathWorks, what the manufacturers of MATLAB, that you know MATLAB, that would be good. So this MATLAB on-ramp thing is free of cost. So you go over there and you launch the course. It should take around, for me, it took around 1.5 hours. At most, I would presume it should not take more than 2-3 hours for you guys. So you go through each of the problems and you need to get it right to proceed to the next problem. And you get multiple attempts to get the answer right. So once you are done, something like this would show up. So this is a screenshot from when I took the course, I think last year. So it would show that your course is complete, congratulations. And eventually you'd generate a certificate like this. So I would develop a folder on the D2L where you would upload this kind of certificate that you are going to generate. And you won't generate this certificate without completing all the questions on that course. And you can show this certificate when you go for possible job interviews as well. So you need to generate this. I have tried to include this particular screenshots, which would help you figure out how to launch that course. And I don't think you have to do it in one single sitting, but I would advise you guys to do it in one single sitting. It's just easier. So make sure that you have a block of time, 3 to 4 hours saved up just for this. And this is due on October 1st. So you have some time to work on this, close to 2 weeks, but do get this done. This would help you later on. Okay, now this is the homework that we have from today's class. So calculate the sum of this series. So here I have tried to get a mix of both for loops and while loops. So this, of course, you know by now because you prepared for the test that probably for loop is going to be more handy. Now over here, you might be asked to use the while loop because I have given you a condition that is to be tested while you develop this series sum. So spend some time to think on this problem, ask the TA during the lab classes. And this last problem is not directly linked to what we did today, things that we have already done in the previous lectures. Okay, I wanted to leave some time out if you have any questions for the midterms, and I can share a solution with you guys as well for the midterm. So the first problem was on developing a series sum, which is exactly like the problem that we did in class. Only the mathematical, the algebraic part was different. So I hope all of you got that correct. And the last part was figuring out the difference between the actual MATLAB calculated sum, which is the inverse sign, and the sum that you calculated from this loop run. So you need to remember that the MATLAB command for sine inverse is a sine, or you could have gone directly to the MATLAB help tool, which you can access anytime, even during the test, to figure this out. So the MATLAB help tool, you should get it from here. So you go to the home tab and you go to help, and then you can search for different things. I said that you should not use any browser, but you can still use whatever is available from the MATLAB platform. But anyway, so this is the most of the points for this particular question was for the main part of the code. Okay, so this problem was really easy. The function development to figure out the value of the kinetic energy, and based on whatever the value is to figure out what the MATLAB is supposed to show as the display commands. This is actually simpler than the kind of problems that we did in the class. And this is the last one from the command window screenshots on introducing the matrix and then doing the different operations. So I'll share these solutions with you. Maybe this would be useful when you prepare for the final exam. But hopefully it wasn't a very difficult, very hard test. Okay, any questions? Okay, so we have a shorter class today, so let's end now. And shoot me emails if you have any follow-up questions. Okay guys, so have a good weekend and I'll see you on Tuesday.